Looking at now is that we're going to be looking at chances, probability, and odds. So in this first section, we're going to be looking more at sample space and how to get and figure out how many possible solutions we have for a given situation. And that's what we're going to be looking at in this one. And then the next one, we're going to be looking more at the probability and odds section of this. Okay. So these two cartoons are by XKCD, which is a fantastic webcomic. It deals with math, science, technology, and different things. I would highly recommend it for you guys to check out. Now, first thing I want you to do is think of a die. You know, that six-sided thing has got a couple numbers on all the sides, you know, something looks like that, okay? So when you think of a standard die, how many different possible solutions do you have if you were to roll one die, okay? Well, obvious solution is that there's six possible answers. You can have one, you can have two, you can have three, you can have four, you can have five, maybe even six. Okay, so you have six different possibilities when you roll one die. That is called the sample space. There are six different. The size of the sample space would be six. There's six different opportunities. Now, if you have two die, let's say you have this green die and this purple die, and you roll those two, you would have 36 different different answers. Okay, there are different possibilities in your sample space. Okay, so that would be the size. Okay, so however many opportunities there are, that's our sample space, and that's what we're going to be looking at. We're going to be looking at different things that we can have for that. Now, think of a coin. So if you flip a coin, how many outcomes do you have if you flip one coin? Well, you have either heads or you have tails. And obviously, yes, that's what you have. So you have two different outcomes. Okay. Now, let's say you flip it twice. Okay, so you have your two outcomes if you flip it once. If you flip it twice, how many outcomes do you have? Well, you flip the first time, you get those two. Okay. You have your head or tails, and then after that you have, if you flip the heads, you can have another heads, or you could have a tails, or you could have, from the tails, you can have a head or a tails. So as you see, we have four now. And then the next time, if you were to flip it three times, there would be eight. And then it would be 16, 32, 64, 128, etc., etc., etc. All right. So as we see, we create some sort of pattern here. And the pattern basically is, for this case, is that we have 2 to the n, which would be 2 times the number of flips that you do. So if you were to flip it 100 times, you would have 2 to the 100th different possibilities of outcomes. Okay? And that's for flipping coin. And that's how you would find this sample space. Right? Now, the multiplication rule. So what we just did kind of goes into the multiplication rule, because every flip has 2. So you go 2 times 2 times 2 times 2 times 2, etc., etc. So now, the multiplication rule. Basically what the multiplication rule is if you have multiple different objects that have multiple different numbers, to find how many possibilities of a combination of one from each of those groups are, you would multiply them together. That's the multiplication rule. Okay. So let's say you're going to your favorite ice cream or yogurt place, you know, like Froyo or Grogurt or whatever the places you guys like going for those types of things. And let's say when you go there, they go, okay, look, okay, are you ready? You have 5 different choices of ice cream to choose from. 5. All right. These toppings they show you, they go, we got 4 different toppings you can choose. And you're like, okay, I like these 4, but you can only choose one. And you're like, okay, I'll only choose one ice cream and I'll only choose one. Then after that, what you have to do is you have to pick, how is it going to come in? Is it going to be on a cone? Is it going to be in a bowl? Or is it going to be in a waffle bowl? You know, it's like a cone and a waffle and a bowl mixed together. And so you have those 3 options. And so now the question is, how many different possibilities do we have? Well, what we're going to do is that if we can take one from each, we will multiply them together. And that's going to tell us how many total possibilities we have. And that would get us our, let's see here, 20 times 3, 60. We would have 60 different combinations we can make from one each. Okay? Now, let's say we're talking about clothes. So let's say you want to go on a date. Okay, and you're like, okay, I got my pants, I got my shirts, and I got my ties. All right? Because, you know, you got to be classy for your dates. You know, you got to be classy. And so you go, okay, how many pairs of pants do I have? And you look, you go, okay, well, I've only got these 3 that are clean and are acceptable. So you go, okay, I got 3 pairs of pants. Now you look at your shirts. So you go, okay, how many shirts do I have? About 8. I got 8 different ones. You know, kind of go with these pants. You know, kind of cool. And then after that, you go, okay, tie. Because, again, you want to be classy and you want to impress her and everything. So you're going to wear a tie. And then when you wear and you look at your ties, you go, I got about 5 different ties here. Okay. And now you go, okay, how many different combinations? Now let's say you want to try on all the different combinations, see which one looks best. Heads up, you better be trying those on for about 2 days beforehand because there's a lot of different combinations. In this case, there's about 120 different combinations because we're going to multiply each of these. So we go 3 times 8 times 5, which would be about 120. So there's about 120 combinations based on 3 pairs of pants, 8 shirts, and 5 ties. See, and they kind of grow really quick, really fast. All right, now, this leads into permutation combination. Now, let's say you have a group of objects, and you go, okay, out of this group of, 15, what I want is I want to grab 6 of them. Okay, I want to grab 6 out of a group of 15. You could think of this as being, people in a group, books off a shelf, keys in a bowl, pictures in a book. Okay. Now, if you were to pick them, and it matters which one you pick first, like if you pick the first one, that one goes on top. When you pick the next one, it goes next, and so on and so forth. Or if you're picking people, you go, okay, you are number 1, you are number 2, you're number 3, number 4, number 5, number 6. Okay. If the order matters, we use something called a permutation. A permutation basically is getting this group where the order matters. So 1, 2, 3, 4 is different than 1, 2, 4, 3. Okay, and 4, 3, 2, 1 is different than 4, 3, 1, 2. Right? These are all different numbers. The order in which you pick them is important. And so what you would do is that the n is the larger number. It's how many there are. So for this case, we would have 15 P6. And the 6 is the R. So how many you want in the group would be the R. And after that, you would plug it in, and we have our little friend, the factorial again. And what our factorial is again, if you had 3 factorial, that would be 3 times 2 times 1. And you multiply those together. Okay? So we're going to be using those again. For this one, you're going to have to do the subtraction before you do the factorial. Remember that. Now, combination is if the order in which you pick them doesn't matter. So you just want your groups. So if I just want a group of 6, instead of these 6 in this order, I just want a group of 6, we would use a combination. The order doesn't matter. So this would be 15C6. And as you see, the big difference here is just that extra R factorial in it. So you're going to find n minus 1 factorial and then multiply it by R factorial. Okay? Okay. Now, let's do a couple examples here. So the first one, how many groups of first, second, and third place finishes are there in a race of 8 people? So you've got 8 people racing, either speed skating or sprinting or something. And you want to see how many groups of 1, 2, 3 are there. Okay? Now, you got to pay attention at this. The hardest thing is identifying if it's a permutation or combination. Now, in this case, I want groups of 1, 2, 3. I don't want orders of 1, 2, 3. So since it's just groups, we're going to be using a combination. Okay? And our combination would be 8C3. And then we would plug all the stuff in, and then we would solve it. And if you were to simplify this, you get it down to 8 times 7, which is 56. Okay? So it's a combination because we just want groups of 1, 2, 3. We don't want the order. Now the second one, out of the 25 movies I own, how many different ways can I watch 5 of these movies? Now this one, again, you've got to make sure you can identify how many different ways can I watch it, not how many groups of the 5 can I watch, how many ways. So if you want to watch, the 5 Superman movies, so the first 4 and then Superman Returns, okay, if you watch them, in chronological order, that's 1. But you could also watch it 1, 2, 3, Returns, 4. Okay, that would be different. Okay, so this one we would be using a permutation. So it would be 25P5. Plug it in, solve, and we end up getting a large number of 6375600. Now, the permutation will always be greater than or equal to the combination. The combination will always be less or equal to. There's very few cases when they're the same, but usually the permutation will be larger. Okay. So hopefully this is a good brief overview of everything that we have for the first section.